Labs. I was actually talking to her. She's going to give you a lot of insights into the world of telecom. Her panel is addressing the challenges of telecoms with DePIN. And Waver Labs is creating an open and shared marketplace for connectivity assets. So Maria, the stage is yours.
I need the clicker. Thank you so much. Yeah, I have a very small brain today. Well, thank you for those guys who have stayed until the end of today. I really hope I can, well, we lost the font, but hopefully we didn't lose the, the shape of the presentation. So yeah, I just want to explain you a little bit why I think DePIN makes sense, or blockchain or decentralization just makes sense to solve some of the biggest issues that we experience in the telecommunications industry at the moment. So my background is 100% telecoms. I am not a blockchain person. I just came to this world through, just sheer curiosity, and because we had a problem and blockchain kind of found a way to solve this problem, or distributed ledger technologies in general, blockchain just being one of them. It's a good way to solve some of the biggest issues that we have as we scale telecommunications networks. So let's just dive into it a little bit. I promise this won't be a telecoms lecture, but hopefully you will learn a little bit more about why DePIN just makes sense. So the telecoms model right now, as many of you might know, is that when you buy a SIM card from your telecommunication service provider, typically this SIM card owner, or so the Vodafone or the Verizon of the world, they own the telecoms infrastructure and they control the entire supply chain of how that infrastructure is delivered. And that brings a lot of issues right now. So for instance, it's really hard to find continuity in the service. There is still like 1/3 of the population that it's uncovered. There is very little awareness of where the connectivity is. So for instance, if I am a sensor company and I want to connect my sensors to a network, I have no real way to know where the assets are and who's the coverage of what and how do I get to connect to those networks, let alone if you are a telecommunications provider who wants to reuse assets from other telecommunications provider. There's very little flexibility, so that means that we build one network with one use case in mind. What it means is that typically networks are built to serve your phones, but not the industry as a whole. So for instance, if a hospital wants to equip the hospital with sensors or put robots that are connected to the internet or offer social care services through the internet, the networks that we use are not built for that, so they essentially cannot cope with these new services. And that brings the other problem, which is the money problem, right? We are building one network for one use case, and that means that if we need to invest in new networks, we really need to deposit a lot of new capital into the cities to satisfy the large variety of technologies that right now exist within networks. Everything exists within networks. So this model is actually not really working. But then I'm a researcher, so I have been working on what has been the path from 3G to 4G, now then from 4G to 5G, and now in the standards community we're sitting down and thinking, what the hell is going to be 6G, right? And we have a set of challenges that we need to overcome as an industry with a new standard, which is going to be 6G. And some of the challenges are that our networks are super complex. They're very, very complex. And if we think about mobile networks, they have so many different layers of hierarchy that it's almost impossible to scale them without like literally millions of dollars in new equipment. And some of the concepts, because obviously now we're global, we don't work in offices, we work from home, sensors connect to networks, vehicles connect to networks. There are some concepts that are quite outdated, like domains. So domains, for you guys to understand, are kind of like, it's like a perimeter that you put into your assets. So it's as if I create a network and then this is my domain. And I don't allow anyone to enter or leave this domain. So that concept does not really fit the way that we use the internet nowadays. It's the opposite of what we think that networks should be. And then there's all this advancement of AI, and I mean, might sound kind of like a hipster here, but AI is not something new, right? For us who have been doing research for ages, machine learning algorithms and intelligence, and analyzing data in order to embed intelligence into systems is not something new. However, it is something that if it's not software-driven and if it's not data-driven, is really difficult to embed in our systems. So how do we actually embed intelligence in this really, really complex system is a big, big challenge that we have now. And then now when we're thinking about 6G, obviously we go to the telecoms operators and we tell them, just tear down and start again. They just don't want that, obviously, for obvious reasons, right? You just want to build on top and actually capitalize on the investments that they have been doing up until now. And the requirements that we are seeing right now for 6G are that we need to embrace automation, so networks that self-heal, that understand, for example, that today we have hundreds of people coming here, so our network needs to be able to respond to that. But then when there are no hundreds of people here, we also need to understand that, and it needs to automatically, breathe in and breathe out. How do we solve issues like indoor coverage? I'm pretty sure that most of you have experienced the problem that you go indoors and you don't really have signal when you go indoors, so that's another issue that mainly comes from investment. How do we collaborate with developers? So if any of you are developers, I'm pretty sure you understand that it's really, really difficult to create applications that are network aware. And the way that we do is we modify our application based on the quality of experience of the user. So we really try to build APIs, but then we fail as an industry to do that because we're not software driven. So that's a big challenge. We want personalized connectivity services, but we don't want to build in platforms. That's a big issue. So AWS actually cracked it. You don't need to create personalized solutions. You just need to create building blocks based in software so that you make it look as if you're being personalized, but you're actually using software for that. And we want more flexibility in the network. All of that while being efficient, secure, and cheap. That's a lot of requirements for 6G when 5G delivered none of that. So we're still trying to figure out how we're actually going to do this. But from a research environment where I come from, there are some industries that actually really cracked this, and distributed systems is one of those, and the IT industry leveraged distributed systems for a lot of things. So I just want to explain you why this kind of makes sense. This is a snapshot of how actually the industry works right now. Very simply, you have companies that are large incumbents that create network equipment. There are not too many, and in this country we've got one of them banned, so we have even less now. They're massive companies. They dictate the innovation and how the telecommunications equipment is built and sold. Then there are two main sectors who build networks. You have those who build networks and then resell that connectivity, who are these third-party organizations, your tower costs, sometimes called, or you have your service providers. As I said, the ones that you use to buy your SIM cards from, they typically build the network. And then there's those who distribute services on top of these networks, who typically sometimes are the same ones who own the network. And then you have those who consume the services, right? So very much streamlined and with a very big command and control from the service providers. So our vision from Weaver Labs to make sense from all of this complexity is it comes through three main elements. One is distributed and based in software, based on cloud orchestration tools that you can actually create networks that breathe in and breathe out. same as hyperscalers have done in terms of AWS, Google Cloud, and Azure, and others. Heterogeneous, meaning that we can connect over multiple domains or ownership areas that if I am a service provider, I don't need to exclusively use infrastructure that I own. I don't need to exclusively use 6G or cellular, that I can use a combination of technologies, that I can use a combination of ownership areas as well. This just, to us, makes sense. And the last one is decentralized, essentially because applications, services, need to be delivered as a result of cooperation of these networks, right? Or of these elements that conform a network. Let me just unpack a little bit this. So our vision is that the network is a service running environment. Each node in the network, it's a publisher of capabilities or a consumer of capabilities. Hey, I'm a router. I need someone to sell me bits. Hey, I'm a fiber. I need a router. Why don't we do business together? And that is a protocol that coordinates this, right? So the application layer says, I need to deliver a video from A to B. So this service running environment understands the assets that it has and can understand how to build a path in order to deliver this service. For that, we need what it's called decentralized operation systems, OSS layers, and these autonomous nodes can join and leave the network as they want, right? But we need to work on protocols that actually are able to create this hyper-scalable, on-demand network of networks. And that's exactly what we do at Weaver Labs. We create a software that essentially, what it does, it allows nodes to join and leave regardless of what they are, if they are complete islands of connectivity or if they are just one single node that joins this network. So how would this look like? So before, we're looking at complete vertically integrated environment, right? We have some network resources, they're owned by the provider, and then on top deliver some service. So very vertically integrated, one network, one use case, one owner. Whereas the way that we see it is that we have an infrastructure layer that is a set of nodes that is governed by a blockchain layer that can coordinate the pairing of these nodes. And then whoever wants to provide a service on top of this decentralized infrastructure can use it, provided that has access to it. And then you have a very varied application layer that benefits from this heterogeneous environment. So we use elements such as service orchestration, IT, cloud, and management and automation in order to do that, right? The service layer, the decentralized service layer, which is the blockchain, resolves a descriptor, a computer program, and understands how to pair these nodes together. So one thing that we realized when we were doing research about this is that actually distributed systems failed and peer-to-peer systems failed to deliver back in the 90s when everyone was using BitTorrent and Napster because they did not offer incentives, right? We did not have an incentive to behave well in this network or to collaborate in this network. So right now, we have seen that with blockchain that actually can change, right? Because using an infrastructure that offers monetary-based incentives actually brings the whole network together and allows this collaboration between these nodes. And the micropayment is a very powerful tool in this context because it doesn't matter if I am a large network or just one asset. I can break down the contributions of these players in the network and do revenue sharing across the players of the network, which nowadays it kind of happens. We do this through very complex service level agreements, but this would be automated and leveraging the on-chain resources. So the solution that we think that might be kind of like the key to solving all these issues is that you can use distributed ledger technologies to ensure that all of these contributions are valid. So if I am putting a certain amount of compute or a certain amount of capacity in the network, leveraging consensus, I can actually know that that is happening. Then we can leverage tooling such as smart contracts to make sure that we can have an agreement between ourselves and say, okay, I'm going to take these resources and I'm going to use them, and then I'm going to release them by X amount of time, and then a payment can be released. And then like that, we can create a network of participants that actually are working for the network, and that they define the roles of who contributes with the telecommunications assets, who's going to maintain the governance of the network, and who's going to consume these telecommunications assets. To me, it sounds like a no-brainer, right? It actually solves the problem pretty much there. So the way that this would look like is that you have your traditional players, that they keep building networks. We're not telling them to stop. We're telling them continue. But there are some areas where others would want to build networks. So for instance, you go to a stadium. There is a capacity issue. Vodafone is not going to go and build a network for a stadium. We know that. But the stadium may want to build a network and offer it to Vodafone to serve their users. So all of a sudden, we have a new set of players that can build this infrastructure and put it as a service to be consumed on demand. And for that, we also have city centers, rural areas, and many other areas that before did not see a value of creating an isolated network. Then using our software, we aggregate all of these assets. We use agents to digitize telecommunications assets from fiber, full 5G networks, and also, mesh networks, IoT devices, you name it. And then distributed services across this network of networks using smart contract and leveraging a native token that it's called a DINO. And obviously, the services on top, you don't really have to care what's happening under the hood here, right? They're delivered in the same way as they were before. So a DINO, it's the token that we have created to test this and to test the marketplace of connectivity. And fortunately, we have had the buy-in from a lot of the industry, so that no one is actually calling us crazy. They are seeing the value in something like this. And essentially what it does, it's a flexible payment mechanism that makes the ability of all of this to happen in the network, essentially. It monitors the network usage. It makes sure that there is a certain service level agreement. So if I am Netflix and I want to have a certain amount of uptime in the network, I need to have assurances of that. If I am receiving some grant to give connectivity into like a left behind area, I need to make sure that I'm delivering that. So a DINO can provide that level of assurances. And essentially, it's just a trustless and transparent way of sharing assets in the industry. So yeah, that's me. Hopefully you're bought into the idea as well. I think we have 2 minutes left. If you have questions, comments, I'm happy to take the "you're crazy" one as well. Not be the first one. Sure. The cultural obstacle of the telecommunications industry. So these guys here, the service providers and the third-party organizations, they love being the incumbent. They love getting all the millions, and they love lobbying the government to maintain their status quo. They are the biggest issue that we have in the industry, not for decentralization, but for everything, for sovereignization, cloud-based infrastructure, anything that has to do with innovation.
Do you think it's going to be some private sector startup that will create a smaller network? And do you think that's the way it's going to go, or will it change?
It's a combination. It's a combination. I think, obviously, you're going to have a de facto standard that is going to be adopted by the industry. So, for instance, our approach is let them be. We're not going to get involved with them. We're just going to go to the venues, to the city centers, and try and solve the issues that they have through shared infrastructure. Eventually, we've all seen the results that they have had in the last quarter in terms of revenues. Revenues are going down. They will have to wake up to the idea of infrastructure sharing, and then obviously there is an infrastructure sharing already platform, ours. But then there is the other thing that goes in line with it, which is regulation and working with the policymakers to make sure that we can build more networks out of the box using spectrum. So we work a lot with government trying to explain how competition is so important in the market. Well, thank you, guys.